Welcome to the heart of global trade. Deep within this massive industrial complex, the most powerful engines on Earth are beginning to take their epic shape. Imagine a structure 10 stories tall, where humans look like tiny ants against the backdrop of towering machinery and the glowing orange forges of creation. These are not just machines, they are mobile skyscrapers. Today, we witness the birth of a 100,000 horsepower heart designed to conquer the oceans. Standing over 13 meters high and 26 meters long, this engine represents the pinnacle of human engineering and the absolute limit of mechanical power today. 100,000 horsepower. That is the combined strength of 30 main battle tanks, all concentrated into a single, massive block of pulsating steel and fire. To build something this large, and every rule of physics is pushed to the edge. It takes years of planning and months of precision labor to complete. From the first drop of molten steel to the final bolt, this journey is a testament to our desire to bridge continents through sheer mechanical force. But before it can roar, it must be forged in the fires of the foundry. Let us go back to where it all begins, the fire. At 1500 degrees Celsius, liquid steel flows like a river of fire. This is the moment of birth, where raw elements transform into industrial strength. The air thickens with heat and the smell of ozone. 300 tons of specialized alloy are required just to form the base of this beast. Precision starts with the mold. Even a tiny air bubble trapped inside the cooling metal could cause a catastrophic failure under the pressure of the sea. As the water hits the red-hot surface, the cooling process begins. This delicate balance of temperature determines the internal molecular strength of the entire engine block. A single mistake during this cooling phase can cost $500,000. If the metal cracks from internal stress, weeks of work vanish in seconds. The thermal stress is immense. Engineers monitor the cooling curves with surgical precision to ensure the metal settles without any hidden microscopic fractures or flaws. It takes days for a casting of this size to reach room temperature. Only then can the journey from raw metal to precision instrument truly begin. Using advanced ultrasound, every inch is scanned. We are looking for the slightest imperfection that could compromise the 100,000 horsepower this engine will produce. Risk is always present. In the world of mega engines, there is no room for error. One bad pour means starting the entire multi-month process from zero. The excess metal is carved away, revealing the skeleton of the Titan. It is a brutal process of subtraction to find the perfect form hidden within. With the foundation cast in fire, the Titan moves toward the world of high technology, where microns determine the fate of the entire ship. Welcome to the realm of absolute precision. Here, we move from the brute force of the foundry to the delicate touch of computer-controlled diamond drills. The CNC machines work for 72 hours straight. They must carve paths through hardened steel with a tolerance thinner than a single strand of human hair. A deviation of just 0.001 millimeters is enough to cause excessive wear. Every cylinder must be a perfect geometric circle to function. Digital intelligence guides the mechanical hand. Algorithms calculate the exact path of the drill, compensating for even the slightest vibration in the factory floor. Automation is everywhere. Robots handle the logistics, but ensuring that the 50,000 individual parts arrive at the assembly line with perfect, just-in-time synchronization. Temperature control is critical. A change of just 2 degrees can cause the massive steel block to expand, throwing off every micron-level measurement taken. In this sterile environment, the engine is transformed. What was once a rough casting is now a masterpiece of mathematical accuracy and mechanical perfection. The honing process creates a crosshatch pattern so fine it is invisible to the eye, allowing oil to cling to the walls under extreme pressure. Each head is a complex maze of valves and fuel ports. The flow of air and fuel must be perfectly balanced across all 14 massive cylinders. Even the smallest holes are critical. These ports will deliver fuel at pressures that could slice through solid wood, turning oil into a fine mist. This is where the power begins. A perfect seal between the piston and the liner is the secret to capturing the energy of a controlled explosion. Now we meet the backbone, the crankshaft. This single piece of steel weighs as much as a fully loaded Boeing 747 jumbo jet. 300 tons of rotating mass. To ram this giant, a press with 15,000 tons of force was used to shape the white-hot steel. The bolts holding this spine together are tightened with hydraulic force. No human arm could ever provide the torque needed to secure these massive joints. A single grain of dust could destroy this entire assembly. The journals must be smoother than glass to prevent friction from melting the metal components. Lowering it into place is a dance of giants. The clearance between the crankshaft and the frame is less than the thickness of a credit card. These gears will drive the camshaft and the pumps, synchronizing the entire engine's breathing with the rotation of the propeller shaft deep underwater. It takes a coordinated team of 20 engineers to guide this single component, and every movement is checked against 3 different laser alignment systems simultaneously. Oil will pulse through these veins at high pressure, creating a thin film that allows the 300-ton shaft to float on a layer of liquid. The balance must be perfect. Any vibration at these scales would be like an earthquake, capable of tearing the ship's hull apart from the inside. The backbone is set. The Titan now has its spine, ready to receive the power of the explosions that will soon drive it forward. Alignment achieved. We are ready for the next stage of assembly, where the combustion chambers will bring this cold steel to life. Now, we enter the combustion chamber. Each piston weighs 5 tons, as much as an adult African elephant, moving up and down with terrifying speed. Piston rings are the primary seal. They must withstand the heat of an explosion and the friction of the walls for decades of continuous operation. A fuel is injected at pressures equivalent to being 2,000 meters under the sea. This ensures that every drop of oil burns completely and efficiently. The heat here is intense. This surface must endure millions of explosions without melting or deforming, protecting the structural integrity of the piston body. Each cylinder produces the power of 10,000 family cars. Together, they create a force that can move 200,000 tons of cargo. Compression is the key. The air inside is squeezed until it reaches a temperature high enough to ignite heavy fuel oil instantly upon contact. The connecting rods are the arms of the Titan. They must be strong enough to withstand the downward force of a 1,000-ton explosion every second. Inside this chamber, the pressure is high enough to crush a truck in an instant. It is a controlled environment of extreme physical violence. Every thousandth of an inch matters. If the piston expands too much from heat, it will seize, destroying the entire engine in a heartbeat. These valves operate in a hurricane of fire. Only the most advanced aerospace alloys can survive the constant thermal cycling of this environment. The combustion heart is sealed. We are now moving toward the final assembly, where the lungs of the beast will be attached. In the final stretch, 50,000 parts come together. Massive turbochargers, each the size of a small car, are hoisted onto the upper deck. 2,300 tons of steel. This is no longer just a machine. It is a masterpiece of modern engineering, ready for its trial. Engineers walk its decks like sailors on a ship. Every pipe and wire is a lifeline, feeding fuel, air, and oil to the massive heart. The nervous system is activated. Thousands of sensors will monitor everything from temperature to vibration, ensuring the Titan stays healthy during its long voyage. Forget one single washer, and this $30 million machine could destroy itself. Perfection is the only standard that allows these giants to survive the sea. $30 million. That is the price of total reliability. When you are in the middle of the Pacific, there is no room for failure. The lungs of the beast are massive. They must process tons of air every minute to keep the fire burning inside the 14 giant cylinders. This system controls the flow with millisecond precision. It is the brain that manages the raw power, turning it into smooth, unstoppable momentum. The final check is complete. Years of design and months of assembly have led to this moment. The Titan is ready to take its first breath. The test bed is the final hurdle. Here, the engine will be pushed to its limits before it ever touches the salt of the ocean. One button press will awaken the beast. Silence fills the hall as the final countdown to the first ignition begins right now. The first heartbeat. A deep roar that you feel in your bones more than you hear in your ears. The Titan has come to life. 100,000 horsepower achieved. Every component is working in perfect harmony, creating a torque that could twist a skyscraper into a corkscrew. But the journey is just beginning. To reach the shipyard, this giant must be broken into massive modules and moved across land on specialized transporters. Moving 1,000 tons of steel across land requires military-level planning. It is a slow, methodical march toward the coastline where its ship awaits. At the shipyard, the modules are reunited. Deep in the hull of a 300-meter container ship, the engine finds its permanent home. The engine is finally connected to the propeller. This bronze giant will turn at only 100 revolutions per minute, but with unstoppable force. The ship is launched. For the first time, the engine and the hull become one, ready to face the challenges of the open sea. At full speed, the engine is a rhythmic powerhouse. It will run for months without stopping, crossing thousands of miles to deliver the goods of the world. This technology is what makes our modern world possible. Every item in your home likely traveled across the ocean thanks to a heart of steel. How many years do you think this monster can run before its first major service? Leave your guesses in the comments below. The Titan will serve for 30 years, conquering storms and connecting nations. It is a true marvel of human ambition and mechanical engineering, ready to conquer the oceans. If you enjoyed this journey into heavy industry, don't forget to subscribe. Until next time, keep exploring the wonders of technology.